Individual materials used in maxillofacial prosthesis. Acrylic resins. In cases where little movement of tissue bed during function, example orbital or ocular, etc., acrylic powder consists of polymethyl methacrylate and liquid methyl methacrylate. The polymerization of methyl methacrylate is initiated by UV light or heat as well as chemical initiations. Heat polymerizing methyl methacrylate is preferred over the autopolymerizing form because of the presence of free toxic tertiary amines and color stability. 2. Acrylic copolymers. It is acrylic and methacrylic acid and made soft by adding plasticizers. 3. Vinyl plastisols and copolymers. Introduced in 1940, the earliest form consisted of a combination of polyvinyl chloride, which is a hard, clear resin that is tasteless and odorless, and plasticizers. Commonly used vinyl chloride vinyl acetate copolymer. The amount of vinyl acetate in the polymer varies from 5 to 20%. Vinyl resins that are relatively rigid in their pure state made flexible by addition of plasticizers. 4. Polyurethane. It is the most recent addition to maxillofacial prosthetics. Initiator used is 1,4-butanediol. It requires accurate temperature control as a slight change in temperature can alter the chemical reaction. The reaction must be carried out in a dry atmosphere or carbon dioxide will be produced and a porous elastomer will result. 5. Silicons. Introduced in 1946. It consists of alternate chains of silicon and oxygen which can be modified by attaching various organic side groups to the silicon atoms or by cross-linking the molecular chains. They have a wide range of properties from rigid plastics through elastomers to fluids. They exhibit good physical properties over a range of temperature. Additives are used to provide color. Most rubbery forms of silicon are compounded with fillers that provide additional strength. Antioxidants and vulcanizing agents are used to transform the raw mass from a plastic to a rubbery resin during processing. The long-chain polymers, when tied together at various points, create a network that can be separated only with difficulty. This network makes the silicons especially resistant to degradation from ultraviolet exposure. The process of cross-linking the polymer is referred to as vulcanization, and vulcanization occurs both with and without heat and depends on the catalytic or cross-linking agents used. The tear strength of a polydimethylsiloxane maxillofacial material is extremely important, particularly at the thin margins surrounding nasal and eye prosthesis. This thin margin helps to mask the presence of the facial prosthesis to the surrounding tissue.